Okay, this is going to be really exciting because what we're going to do is we are actually going to get a feel for some form of analysis. And what I'm showing you here is the data file that you actually opened via sample, and it's called bank loan SAF. All right. Now, what I want to do is show you some very simple analysis. Okay, what you're going to do is move the mouse to analyze. When you click analyze, go to something called descriptive. All right, and let's go to the first bit called frequencies. And I'm just clicking on frequencies. All right, and this is exactly the screen that you get. If you notice on the left side is all these variables here, branch, encast, all these are here. And these are the variables that you want to actually use for purpose of determining your frequency. Okay, so what I want to find out is just simple things like branch in terms of frequency. I just go here because it's highlighted here, I click. All right, and all I need to do is just go OK, and you can see what happens. Automatically an output file opens up with the actual frequency. All right, now let's just try to understand this. All I did was I went to analyze earlier, I went to descriptives, I went to frequencies, and what I did was I had branch, which was over this side, and I actually want to analyze it, find out the frequency, and that's all I did, and I pressed OK. And what did I get in return? This whole output. Now, by looking at this output, I should have an idea or be able to interpret this output. Now, what does it tell me? When I see number 3, number 13, number 15, and I've got a frequencies of 100, that means there were 100 respondents who were from branch number 3, all right? And branch 13, there were 100, and so on and so forth. And whereas this column here gives me the actual percentage, whereas here is the valid, because in some cases there may be missing values. We do not have that. And the last one is cumulative percentage. So it's 6.7, and then this adds on and goes on, and the last one is 100. Okay, so this is a typical output file, and all we have done is simple frequency distribution of one variable. Now, let me just take you back to the same data file. Now, if you look at the data file now, go to analyze, and I'm going to go to descriptives, and go to frequencies, and I'm going to make it a bit more interesting. All right, if you notice, branch was actually a nominal scaled variable because they had branch numbers. All right, and what I'm going to do is I'm actually going to put age in years, which is ratio. All right, and see what the computer actually does now. If you notice, and see what it does. Okay, now what it's done, if you look at it here, in terms of branch, we had the same output. And look at age. Age, it's given me for each individual age what was the frequency. For people who are 18 years old, their frequency was 17, 19, and so forth, so forth. So normally, you would not want to have frequency distributions for ratio scale variables because, you know, unless you want to know specifically certain age groups. I mean, look at those in 79ers 1. You want to have frequencies for nominal scale variables where they are in certain groupings. Okay, so like I said, the computer or SPSS will literally give you anything you want, but the question is whether it makes sense and whether it does any good for you. So now we've done a bit on frequencies, and let me just show you the possible variables that will make sense when you use frequency. Now here we've got level of education, which is also a bit of a nominal scale, and this one here previously defaulted. So these are three variables. If I run frequencies, it will make a bit of a sense in terms of its output. Now look at the output. Branch number makes sense. Level of education. Okay, we've got those who did not complete. What were those? All right, and those previously. Whereas if I showed you the one in terms of age from the early output, it was just an array of numbers which really would not be of any use to you. All right, and so that's what we're talking about in terms of frequencies, and the other bit in terms of analyze is called descriptives. Now, what are descriptives? Descriptives are descriptive statistics, and again, I'm going to show you descriptive statistics. Let's take maybe age in years. Put it in here, and I'm just going to go to options, and all I want is mean, standard deviation, minimum and maximum, and that's all I want. Leave it as default, and I go here, OK. Now, look at what the computer has given me. It's hardly a split second. I get age. There were 1,500 respondents. The minimum age was 18, maximum was 79. What's the average? 34.17, and standard deviation is 13.142. Now I want you to go and read up about what is meant by standard deviation and mean, because standard deviation is just an average, whereas mean is just an average, whereas standard deviation is the level of dispersion from the mean. It is the degree of spread. All right. Now, what I've showed you now is this. Now let me see, and I want to show you another descriptive statistic. I go to descriptive. You notice I have an age here, and you can actually ask the computer to analyze anything, and it will. Now, if I go and say analyze branch, all right, this is nominal scale, and this is ratio. And look at the difference, and tell me what the output is all about. Okay, look at the output here. Let's look at the output. The first one, age in years, makes sense. Branch is nominal scale. They've got 52 as the mean. Does that make any sense? Are we trying to say the average number 52 is the actual branch, so to speak? So I want to come back to this, but in the meantime, I want you to actually have a look at this particular descriptive statistics between age and branch, and tell me, or think about it more in detail as to which really makes sense. And I'll start the next session with this.